Hello dear students, welcome to the channel and very welcome to this playlist in which we are discussing about 8051 microcontroller in detail. And today I am changing the format of today's class a little bit because I think to discuss the stack I think the book is more preferable than having a slides. So we are switching to book for this particular lecture, and today we are going to discuss about stacks and subroutines in detail. If you want to learn about the playlist, in this playlist we have discussed about the pin diagram, block diagram, the different of types of interrupts, timers, memory organization, uh, different ports available and the programming of ports, different program instruction and their groups, and addressing modes of 8051 in detail, and many more. So if you want to learn more about 8051 microcontroller in general, you can check out the playlist of microcontrollers. The link for the playlist will be flashing in the top right hand side corner of your screen in the I button. So just click on it and it will lead you to the playlist. Now that out of the way, let's start discussing about stack. And for stack, we are using the same book that we use for microprocessors because it pretty much serves the same purpose. So the stack in 8085 microcomputer system, it can be described as a set of memory locations in the read-write memory, right? And who specifies the stack in the program memory? So you, the person who is programming, specifies the stack in the main program. So these memory locations are used to store binary information in bytes temporarily, okay, for part-time purpose during the execution of the program only. Once your program is executed, then the stack memory will be cleared. So the beginning of the stack is defined in the program by using the instruction LXISP. Okay, it may have been different in different microcontrollers and microprogrammers, but in 8085 we use LXISP. So it loads the 16-bit memory address in the stack pointer register of microprocessor or controller, and once the stack is loaded, then the location is defined, and storing of data bytes begins at the memory address that one less than that is one less than the address in the stack pointer register. Let's understand this with the help of an example. If stack pointer register is loaded with the memory address 2099H, the storing of data bytes will begin at 2098H, and it will continuous in reversed numerical order. Okay, decreasing memory address such as 2098, then 2097, then 2096, and so on. And therefore, as general practice, the stack is initialized at the highest available memory location to prevent the program from being destroyed by the stack information. So the size of the stack is limited by only the available memory. Clear? Now the data bytes in the register pair of the microprocessor can be stored on the stack in reverse by using the instruction push. So the data bytes can be transferred from stack to respective registers by using the instruction POP or POP. And the stack pointer register tracks the storage and retrieval of the information. Now because two data bytes are being stored at a time, the 16-bit memory address in the stack pointer is decremented by 2, and when data bytes are retrieved, the address is incremented by 2. Simple. And what does this address indicate? So the address in the stack pointer register indicates that the next two memory locations that can be used for the storage purpose. Okay, and that also takes place in the descending numerical order. So as you can see, we have some instructions here, And stack is something that is shared by microprocessor itself and the programmer. Although the control over the stacks would be of programmers, programmer can store and retrieve the content of the register by using the push and pop instructions. This is I'm talking about microprocessor 8085. And similarly, microcontroller will automatically stores the content of the program counter when subroutine is called. Okay, and that we are going to discuss in upcoming section in this class only. Now let's see some of the instructions of 8085 microcontroller for stack operation. So you have this LXI, which loads the stack pointer. And always remember, in microprocessor, we have 16-bit stack pointer. Then this push instruction, with different operands we used to have the opcodes. So this push opcode, when used with RP, it will store the pair on the stock. When we use push with B, then it will copy the content of the specified register pair on this stack as described here, as you describe in your program, by the way. Then we have push D, push H, push PSW, and so many. And then we have pop as well. Okay, so because these instructions are 8085 instructions, so we are not going into the detail of it. If you want me to make a video on it, just ask, I will make a separate video on it. Then they have discussed an example. Although we would have visited the example, but this example also happens to be 8085 example, so we will not be visiting this. Similarly, we have 2-3 examples. Okay, this whole portion is an example. This is the review, and then we have the real life problem itself that we will be dealing after completing the whole theory portion. Now let's come quickly to the subroutines. So what is a subroutine? So subroutine is basically group of instructions which are written separately from the main program. Okay, group of instructions which are written separately from the main program to perform the function that occurs repeatedly in the main program. Okay, now you may have a question that how, sir? So for example, if a time delay is required between three successive events, 3 delays can be written in the main program. And to avoid the repetition on the same delay instructions, the subroutine technique is used. So delay instructions are written once, then separately from the main program, and they are called by the main program when needed. Okay, and this microprocessor 8085 has 2 instructions to implement subroutines: call and ret. Call is used to call a subordinate or subroutine, and ret or ret is used for return to main program from a subroutine. Okay, if you want to call a subroutine, use call instruction. If you want to return to the to main program from a subroutine, then just write return. Now when we use call and when we use ret or rate, or we some people also call it a return. So the call instruction is used in the main program to call a subroutine, and ret instruction is used at the end of the subroutine to return to the main program. So when a subroutine is called, the content of the program counter, which is what is the objective of the program counter, so it gives you the address of the instruction, right? So program counter will give you the address of the instruction following the call instruction, and it will be stored on the stack, and the program execution is then transferred to the subroutine address. And when the return instruction is executed at the end of the subroutine, the memory address stored on the stack is retrieved, and the sequence of this execution is resumed in the main program right from where we left off. Okay, so as you can see here, we have call and return instructions, the opcodes and the operand. What would be the operand? So it would be 16-bit memory address of whatever subroutine you want to call. So first we have the unconditionally call subroutine, which is a 3-byte instruction that transfer the program sequence to a subroutine address. Then it saves the content of the program counter, the address of the next instruction basically, on your stack. And then what do? We decrement the stack pointer register by 2. Once we are done with the decrement process, then it will jump unconditionally to the memory location specified by the second and third byte. So the second byte specifies the line number and the third byte specifies the page number. And this instruction is accompanied by return instruction in the subroutine. Once you are done with the instruction, then you mention return. So return is a single byte instruction, unlike call which was 3-byte instruction. And in return you insert the 2 bytes from the top of the stack into the program counter and increase the stack pointer register by 2, and then you unconditionally return from a subroutine. Now let's see an example, the exchange for information between stack and the program counter for this program given here, with the help of memory address 2000H to 23FFH. So see the program. First we have executed LXI SP2400H, which initialized the stack pointer at 2400H at memory address 2000. Then we use the call instruction at 2070H to call the subroutine which is located at 2070H, which is a 3-byte instruction. So then see, we skip 2041, 2042 and then directly jump to 2043. So before that, the next instruction would be the address of the next instruction will be following the call instruction. So the 205F will have halt, which will be the end of the main program. But before that, we directly have jumped to where? We have jumped to 2070 because of this call program. Now that we have jumped to 2070, we have our first subroutine. So this will be the beginning of my subroutine. The instructions of subroutine will get executed, and let's say my subroutine is ending at 207F. So there we have written RET. That would be the end of the subroutine. And then 2080. Remember, we are not operating on decimal number system, we are operating in hexadecimal. So after 207F we get 2080. Then we get other subroutines. We end that other subroutines that as well, and then we will have empty stack. And also remember, the stack pointer was initialized at 2400 as we mentioned earlier. What would be the solution? So we have to follow these steps. Okay, so because we have to see if the program is available to use available user memory ranges from 2000 to 23FFH. First, the available user memory is from 2000 to 23FFH, right? 1000 kilobytes, sorry, 1000 bytes or 1 kilobyte. However, the stack pointer register is initialized at 2400H. So one location beyond the user memory, this allows maximum use of the memory because actual stack begins at the 23FFH. So the stack can be expanded up to location 2398H, without overlapping with the program. And this main program will be stored to the memory location 2000 to 205fh as we saw earlier. So this call instruction will be located at 2040h to 2042h because it is a 3 byte instruction, and the next upcoming instruction will be executed at 2043h. So that what we saw earlier. See, it's a 3 byte instruction. So 2040, 2041, 2042, all three have been occupied by call instruction. Then we next instruction is getting executed at 2043h, and the subroutine will begin at the address 2070h and it will end at 207fh, as you can see, right? 2070h first subroutine, and then 207fh the return. And here you can see the execution of the program, although I recommend you to do it in the KL, then you will be able to understand it better. So they have mentioned the call and return expression in detail, but this is about 8085, so we will discuss about 8051 when we get a chance. And there is a good example of traffic control signal as well that I reckon you do. I think it would be better if you make a separate video on it. So let's keep this class till here only. Next class we will be discussing some of the programs which would be more beneficial to discuss about. So let's wrap today's class till here. That was the stacks and subroutines, and we have also discussed pretty much about this. So I think from next class onwards we may will be able to discuss about the programs in detail as well. So thank you very much for support, guys. Keep watching the videos, keep learning, and if you have any doubts or queries related to today's class or any of the previous classes, please mention that in the comment section below. If you have any queries, if you have any suggestions, video recommendations for me, if you want me to make videos on different topics, please mention that in the comment as well, so I will check them out and I will try to make a video on it based on your recommendation. If you have any feedback related to channel, playlists or videos, mention that in the comment section below as well. Based on that I will understand that what improvements that we required and what changes we can make to draw our channel and uh, make your lessons much in a better way. So that's it for today. Keep watching, keep learning. I will be seeing you next time with a new video with programs. Till then, thank you very much for listening and goodbye for now.